Hello, everyone. Welcome to the second episode number 2 of Crossing the Streams. I'm Matt Yankovic. I'm here with my normal co-host, Tim Span. Tim, how you doing?
Good, good, good.
Today we're joined by the one, the only, Matteo. Matteo, how are you?
Hi everyone.
He's
Good,
very
thank you.
shy today, isn't he, Tim? He's shy. Is it just
I'm
me, or
always
does
shy.
Matteo? Don't be shy, Matteo. It's okay. So, for those who don't know, Matteo is one of the original founders of Apache Pulsar. So that's exciting. So we figured if we're going to explore the streaming world, we should probably bring on someone who knows how it all started. So, Matteo, I'm hoping that you can start with telling us a little bit about the good old days. The days before Apache Pulsar, the days before you had something that, did what you needed it to have done.
Mm-hmm. We are going back many years.
Yes. Yes.
So it's really a journey in the past here. But so I was working at Yahoo back in the day, and we had a good wealth of different technologies in this space. So there was an era where basically like all the big tech companies they had to build in-house stuff for sort of a bunch of issues from databases. There were I think there were like at least 5 or 6 different distributed databases in Yahoo to log aggregation systems to messaging system and stuff. So there were like multiple different technologies, some of which were dating back from the 90s, which was like very fascinating to see like things that you go on this. The first week I joined Yahoo, I was like, okay, now you're maintainer for this library and this system and I was checking the CVS log, and it was like dating back to 96, I guess. And so with kernel modules for BSD and Linux to make it faster. So and this was like basically a middleware messaging stuff. So there was that. There were like other systems built on top of it. So there were like really a wide variety of technology that were built through the years for different purposes and different with different trade-off in mind. And we started working with messaging in the context of database replication. So in Yahoo, there was a very powerful new project that was called Sherpa. Basically, it's a distributed key value store with event consistency. We're talking about 2010, and that was based on a paper from Yahoo that described this system that was very fancy in the way that the version control was done with vector clocks and different complicated resolution policies and so on. And the paper was very nice and say that basically all the replication from database replicas within a same cluster or within different regions are going to happen within this message bus. And the paper was leaving the implementation of this message bus as an exercise for the reader. So eventually that was one thing, and therefore like there was one initial attempt to do it, and that was not successful. And then there was a second attempt. It was going back to the kind of like old school approaches, that thing that were really working, not fancy, but using NFS filers and using things on top of that and so on. And the thing is that it did work, but it did work up to a while. And then we kind of like figure out that kind of like in the bad way, you figure out where things break, right? Up to which point you can stress a system before it just basically you reach that point of no return, in which okay, we have to kind of like cut it off, lose the data, and restart fresh because that thing doesn't scale up. And basically, as a message bus, the worst kind of scenario is when you accumulate a lot of data, and that is also normally the thing that people don't test when they test the message bus, they test only the happy part where the data is consumed. But the real problem is when the consumers are not consuming, and then you build up these terabytes and terabytes of data, and now you want to consume it, and now you figure out that, oh, I'm not able to read faster than the writes are coming in. So what do I do? Yeah, I'm digressing a bit. I'm taking the wrong route here.
Yeah, that's really fascinating, though, because what you just said was the whole reason Pulsar came about is because of databases, right? Like, so the database replication is where it really started, was between these disparate systems.
Yes, so that was one of the.
He said yes. By the way, Tim.
Ideas.
So you see, my argument that everything is a database related problem is true.
Database is the problem. Yes. Stop storing data. Don't store the data. Everything works.
Yeah. Okay. So sorry to interrupt, Matteo. I just wanted to get that on the record that it's always a database thing.
But I would add to what Tim said that it's similar for messaging system, right? Don't store the backlog and everything is fine, right? So if you don't have to retain the data for extended amount of time, then it's an easy problem, right? The problem is when you want to have the data back in all the scenarios, and faster and fast enough. So that's where the things become interesting. But yeah, so database replication was one, and probably the biggest one in terms of volume and in terms of challenges, right? Other one was also to come to the realization that Yahoo had been a big company with a lot of engineering teams, different product teams from a number of different product lines, and all of them, they had several needs in the realm of messaging, right? And many of them, they were using things either done by themselves, like things like a queue on top of the database, for example, to using things like ActiveMQ or RabbitMQ or other things, TIBCO, or like there were really a huge number of things, or Kafka even at some point. So the problem was that each of these product team, they were like coming up very enthusiastic. Okay, and there's technology X, I will deploy it. A 3-node Kafka cluster or a single node ActiveMQ thing, and it's fine. I'm doing my prototype and everything works. Now we'll go to production and things break. And this product team, they don't have the expertise to run it, to maintain it, to figure out how to fix it. So
right, because they just put it up there because they had a need. So they just we need to send data, but I don't know how to run it or set it up.
Yeah, I don't know how to run it. I don't know how to fix it. And so that was basically this push of having everything should be a cloud service. That was like when AWS was coming out, 2010, 2011. So there was mandate. We should build cloud service, internal cloud service for everything, right? But the direction there was that instead of having like each team running their own thing, let's have a single team running a service for the company.
So when you have that mandate, though, why not use one of the other technologies that are out there, right? So if you've got some people who have Rabbit or Active or TIBCO, or you have some people who are running Kafka even, why not settle on one of those?
So yes, so first of all, at that point, Kafka was not even there. But anyway, Kafka was really coming from a different world. Kafka was really just doing log aggregation from HTTP servers to HDFS. There was like no replication. I mean, no message queuing. There's no message queuing even today. But at that point, it was really not durable, not replicated, and so on. So the first mistake that was done was that people want JMS. So basically, the mandate was we need to have a kind of like a JMS service, and because people are using JMS, people are loving JMS. I think that the first part was true, was halfway through. The second part was definitely 0% true. Nobody
loved JMS?
No.
Tim, you love JMS, admit it.
Oh, yeah, that was the way, man. When there was nothing else, it was awesome.
Your option is nothing,
when there was nothing else, and the main problem with JMS was that it was designed, again, it was an API designed in the 90s, which was great then. I mean, I have some opinions as well, but it was greatish then. The problem was that it was designed in a world where you had one server, the server that you take down for planned maintenance at Saturday 2 a.m. and then you bring it up again, and that's it, and you do your operations. But that was not the case anymore. So what we really had there was that you should build this GMS as a service kind of thing. So what we kind of like figured out there was, okay, let's take ActiveMQ and let's swap it in a durable storage. And then we can build service discovery on top of it. And then we can build some kind of orchestration to push topics from one ActiveMQ broker to another, right? And then we can add replication on top of it. So we built all this stuff and we use Bookkeeper as the durable storage, right? That was the initial version. What was called the cloud messaging service. And it did work. And we put like the first production user was actually desperate to get something in production very quickly, and we were their only choice. Were like these ads. There was a new ad platform that had to go from zero to production in 3 months, and they okay, let's use your service, guys, and they went to production, and it did work, and it was mission critical. The problem with this JMS and ActiveMQ stuff was that JMS was designed for a different era, not for a cloud service, and not for a service where you have nodes coming up and down every few hours, right? When you do like running upgrades. And the problem was that the API was so complex to use for the users that each time we had a running upgrade, there was some exception in the client side, and the application developers were not catching all the exceptions in the correct way because it was freaking impossible. And each time the new user that we had them do a running upgrade, everyone was left out. Because the exception, they're not able to process it correctly. They basically got outage because of that, until they figure out how to catch all the exceptions, and that was really painful. And there are many weird things in JMS. So the point there is that JMS was really not a good fit for like building modern application anymore, and there was a lot of baggage there from early. I mean, the model of the messaging, the kind of use case, there was a need for that, right? But the API itself was not, didn't. I mean, it's very difficult to design an API that can age for like 20 years, right?
So you have like this system that isn't meeting your needs. So at some point you have to say, we can do something better, right? Like,
yes.
How what did that look like coming up with that?
Yeah. So there was like two problems. Like one was the JMS, one other was ActiveMQ, which again we were seeing the limitations of the technology as well, and the way that we were boxed into that part. We saw that the storage part was solid. Like Bookkeeper was scalable. We could use that. So the other part is that if you start and say, I want to start a new project and throw away what we started the last year and so on, that's really a bad, you're going to have a bad time convincing people that is the good choice, right? Like rewrite from scratch something is always very risky. So the way we kind of like sold this to the upper management was that we're going to open a different port with a different protocol that is more suitable for more scalable use cases. There's not a rewrite, that's just like a different port that runs in the same service that's kind of like more scalable and more efficient. That was kind of the theme there. But eventually, yes, it was a rewrite. Eventually, it was like an incremental rewrite of the broker.
Okay.
But with the additional problem that you have to do that by while you have maintaining a code base that is in production. So you have this main line that goes in production, and now you're adding a second line which goes bigger and bigger, and for this new service that that is completely different, essentially.
No, yeah, and so back then you're looking at this new service, and you probably had a very narrow set of use cases for Yahoo, but then it started to grow as you started to look at open sourcing it, and you started to add more functionality. So, I mean, like looking at Pulsar now, how has it grown beyond where you started? Like, what was that growth like, and what was surprising about that? That evolution.
Mm-hmm. Yes, I mean, of course, it has grown many lots. There were like also, although several use cases in Yahoo as well, right? So yes, because we had like at some point like 150 different teams using Pulsar, right? So there was already exposure to a really decent set of different style of use cases there. From pure like data moving through the databases supporting database replication through the message queuing, like for things like Yahoo Finance, Mail, like all kind of different ways of using message bus. We've seen a whole bunch of them. So after it was open sourced, and when we started the first company around Pulsar, basically we really sat down and thought, okay, what are we missing, right? Okay, what is that we haven't spent the time before for doing that the people were asking us to do. Let's think what people might need instead, right? So, and also try to fill up the gap with what other systems in this space was supporting. So we started adding things like compaction, which Pulsar didn't support before, or we started, okay, let's try to redesign the API to support typed message, have typed API with the object instead of just bytes, and have first-class integration with schema registry. That was another decision there. So when we did the Pulsar 2.0, all these breaking changes went in, right? And as well, we started try to see how can we make processing data in Pulsar more accessible and easier? And then we started with Pulsar functions, and then added on top of that, we added the connector framework. So all these kind of things that were more added out of how can we complete the picture for this technology, instead of like someone coming up and can you please add this feature, right? It's more like proactive there into trying to figure out what is the next thing that we can add that will add more value, as in completing the circle.
Yeah. And so, with those that expansion and looking at the use cases that you initially had, Yahoo is a very big company. Is Pulsar really designed for that large scale, or is it still usable and accessible for the normal users now? I mean, or have we just changed how we're building applications? So, a messaging or event system is required for modern applications.
So the thing is that typically when you design system for large scale, you can make it work for a small scale too, right? It's not is the only typical problem that you see is that there are more rough edges and more complexity than something that was designed for a single node, for example. But it is not difficult to make it work. Yes, it was designed for a single cluster of tens or hundreds of nodes and so on, right? But eventually, after open sourcing, there were many examples of user running a 3-node cluster or or 10-node cluster without any problems, right? And the other thing was we even did a lot of work to minimize the footprint of a single node. It's called the standalone, right? A single every single node that runs everything. To the point that you can run the standalone service in a Raspberry Pi with minimal resources on the ARM processor, and it is really actually a very good model to run a messaging hub at the edge. For example, like you can have very cool things with sensors that send data to a single local hub, and collect all this data. And now you can run Pulsar functions, like using a one thread per function, or and then using Pulsar on a connector to send data somewhere else, or using replication to replicate from the edge into a cloud service, for example. So it is very flexible that you can run a single node with very minimal resources, and then using the same protocol, the same system. Essentially, it is the same code, the same system that runs, and then replicate and send data into a giant cluster of hundreds of nodes.
Yeah. I mean, I think that right now where we're at from a development perspective or a design perspective, we think of like a small system. Like you look at like an e-commerce site or something, and you think like, oh, it's a website and a database, right? And so classically, that's what most people would consider e-commerce. But now, when we start to look at the cloud native side of things, and we look at how you have to interact with all these third parties, the reality is you end up having a website that connects to a database, but then you also have to connect to a payment processor and exchange data with a payment processor. And then you have to exchange data with a service that does like, warehouse and inventory, and another service that, has the capability to do shipping and, like order fulfillment. And then you have, access to another system that says, oh, we're out of, or, like this widget. So I need to reorder more. And so you end up having one thing that we would classically in our minds probably mistake for a very simple application, but it ends up having dozens of components, and each of those components needs to share and collaborate in near real time and exchange data. And they're all very decoupled systems by design, but that makes something like Pulsar or other streaming messaging systems more valuable. Now, certainly you could do it on your own, but then you're taking the responsibility for all of the HA, the security, the guarantees on yourself.
Yeah, definitely. I think you describe very very well the shift. I would add here that I think that there is also like a mental shift in. I mean, we've seen that in many application developers and in this to think about as the writing into the database. So you have your web app that writes into the database and so on, rather than to see that as an event that happens in the system, right? Say a new user, a new order, a new thing that happens, and so on, right? A new comment, and so on. So like all these, you can treat them. Think first and foremost around them as an event that happens in your system, and then kind of like this, you kind of see this in a slightly different way, right? As in that you first see this as something happening in the system. I can publish this on a topic, and then everything comes after it, right? So basically, after this event has happened, now I have to do operations X, Y, and Z, and that can be done in parallel, it can be done independently, and so on, right? Rather than seeing that user clicks here, I write this into that database to record this fact. Instead, like changing a bit the model there.
Yeah.
And please.
Oh no, go ahead. You were finishing your thought. I was just agreeing.
No. That after that, so if you kind of like change that perspective, I think that it makes much more natural, right? And I think this is something that I've seen it coming. Like when people like rethink their architecture a bit, their design. That's the first thing, the first shift, like this meta shift of seeing reasoning of your like a business domain in terms of event that happens in that system.
Yeah. No. I mean that's a good point. Tim, what do you think?
I know I'm lost for words here.
Tim's been really quiet on this, so I figured I'd give him a chance to chime in, monopolize the time.
There's so much going on, man. I think it was a lot more difficult before, and now it's a lot simpler. Other than the fact that now you have so many options and so many different things going on. I used to work at a online bookstore, not the guys with all the money. And you would think the simplest thing in the world, it's just books. But, then you got to talk to the gift card processor who uses soap, and there's a delay on when they get stuff back. And then if you order more than one thing, you have to figure out how do you eventually get the order together, because some pieces of the order are coming from a partner, some are coming, printed on demand, some are coming from warehouses in different places. So you're trying to build up, a process while it goes along, and things are stored in multiple systems. And then how do you sync those up? It's just crazy. We had like 3 different messaging systems in there. It was like, what do we have? I think Oracle JMS. We had MQ series, and then we had ActiveMQ, just to like, and then someone had an app that would listen for one to come in, change something slightly, check something in a poll, then push it to another message queue. And then it would go make a SOAP call to a third party thing. And if we didn't get a message back, then put it on a different queue and it would call something else.
Okay,
And it's like, so I can buy 2 books.
So the natural question when you talk about like that's a very legacy enterprise environment, right? So you've got, a lot of different, applications, kind of all legacy. But isn't the new hotness now streaming? So that can get rid of all of that complexity, right? We just stream everything.
Yeah, you start everything fresh. Everything's a stream, and every existing partner and service you use are just going to give you access to a real-time stream. And it's perfect.
Right, yeah, that's right? I mean, Matteo,
You're like,
right?
oh, yeah, I'm going to use this payment processor who's, haven't updated their systems in 10 years because they're afraid of security constraints. They're going to give me a live streaming connection.
Okay, but we have to settle this, right? So, like, I asked this last week. Matteo's on now. Look, there's a lot of confusion between whether you still need messaging or everything should be a stream. There's a lot of confusion on the difference between what a stream and a message is.
That could be a whole week event.
Yes, but we have time here, so someone
right?
tell me.
If you ask different people, you will have different. You will have different answers, right? So depending on who you ask, you have different results there.
Okay, but I'm asking you two.
Yeah. So I have my answer. Some people might not agree with that, but I'm okay with that. I think that is not the clearest one, but to me, if you look at messaging, so you can call it messaging streaming or A and B, X and Z, X and Y. It doesn't matter, right? There are 2 main divides, I believe, that in this kind of field. One is the application domain, in which basically you are kind of like you have a set of services, a set of components that are collaborating to generate the new events. The events are not there yet. So for example, like creating a user account or creating one order. Now, the fact that I publish a message on one topic, that makes that account to be created, right? That is the action that gets written, that the account for team has to be created in the system. And then many different components will pick up that message, and someone will write in the database, someone will send an email notification, someone will do something else, add into the billing system, and so on, right? So that is kind of like the event happens as it is published, right? The other side is more on the analytics side, right? So if you look at it now, the way, again, these are 2 different patterns, macro patterns of how you use messaging systems or streaming system. So, the second pattern is analytics. So you have events that have already happened, and for example, like you read log files from your application service. Again, that's one example. Like there can be many different examples here, right? So you are getting these log files and you are ingesting them into topic, into message bus, and now you're running real-time analytics on top of them to extract information and to do something out of that, right? To power your dashboards and or to have some feedback loop that goes in and then update something else, right? But the difference, as I see it, is that these events were already there. The thing has already happened. You just like use the message bus as a kind of like a good infra abstraction in order to process them, right? To aggregate them, move data from one place to another into a different form, and then analyze them. But it is very different, the purpose that you're doing, from the microservices interacting between each other, right?
Yeah. So, okay. So I'm going to paraphrase how I understand this. Let's be honest. When we talk about whether it's Pulsar or whether we talk about Kafka, when we talk about the MQs, the goal is to move some piece of data from one place to another or make it available to one place or more than one place, right?
That's
It's that.
one goal. That's one goal.
Okay. Okay. So it's the movement of data, right? It's the
It's not just that, right? So it's that for analytics, right? But if you look at the first use case, at the application domain, it is not just moving data from A to B. It is becoming the source of truth of what happens in the system, right?
so you're talking about an audit log for it. You're talking about like
The audit log is one use case, right? But say that if I publish a message that say that team account has to be created, that is the intention, right? So create an account for team. Now, as I say, it can be written into a database. It can go to the audit log. It can go to all the stuff, right? But that message, that topic, it is the source of truth for all the account creations in the system, right?
Yeah. So, but
It is
again,
not more like moving data from A to B, right? It is recording that fact, right? And then you can use that in many different ways, right? In many different strategies. You can route messages and slice and dice in very different ways. You can use them as a queue and then have workers, but then maybe service B might want to process them in order, for example.
yeah,
All these differences right there, right? But the point there is that is kind of like application domain versus data domain. And data domain is you are getting data from A to B to analyze it. Application domain, you are enabling the feature by being the source of truth between these components.
yeah, and I mean, I guess maybe I'm minimizing when I say like moving data from A to B. I mean, when you have an application and the application needs the other applications to act on an event or act on, some interaction, that's also in my mind because I'm a data guy. Like it's data flowing between the systems and guaranteeing that action actually takes place. And that's where you get more of the event driven like monikers, right? Because it's like application A or this thing triggers an event, that event gets written, and then that event gets executed on, or something happens based on that state, or that change or that command that's run. So in your case, adding the Tim account or canceling the Tim account or whatever, it's somebody's, let's say in an app, they're on a website, or maybe like the HR system says, we just hired Tim, so his start date is today. So today, let's fire off and add those messages. And then each of the other systems that subscribe to that say, oh, I have a new account for email. And then whatever system's handling, access to Google Analytics all of a sudden adds it, and so on and so forth. So I don't think we're saying different things. I think it's just maybe I use the wrong terms there, which I get. But I think my question and how I'm trying to clarify this from a streaming perspective, I think it gets back to semantics because it's just how you're consuming or how you're using that data is really, in a lot of cases, the differentiation between what a lot of people consider a stream and a message, correct? It's more of, like if it's
That's
a stream, then you can do analytics on it and you get the whole full log. Where if it's a message, it seems more transient in nature. Is that what I'm hearing?
Yes, I believe it is one part of it, right? So typically, like when you are in the application domain, the way to route messages to different consumers and different workers, but it is basically task to do, right? For example, that's most common thing, right? So you have some work to do to process that message, and typically that work is that routing is complex, as in that you might want to have different strategies. So one, for example, like I want to be able to add workers. I'd imagine that, okay, creating accounts is a very expensive operation, it takes 3 seconds, right? And you might want to be able to create thousands of accounts per second. So what do? You have to have many workers, right? So at the point, basically, you can see your topic, your source of truth of topic as a queue, right? That's how you see it, right?
Mm-hmm. Mm-hmm.
Irrespective of how things are implemented underneath, right? But you can map your problem into a queuing problem, right? So now it's a queue, and you can add more work to that pull work task out of that queue. So that is very typical, right? In the traditional streaming, the consumption, it is much more simple, right? The consumption is simple because you see this stream as your thing that your past events, that thing that happened, and now you're looking at them. So you do a scan, a pass to them, right? But you don't even have to acknowledge the processing, right? That's your checkpointing typically in streaming system, right? So that's not even. While in messaging you have a concept of acknowledging, right? You receive something, do something, acknowledge that you have done the work, so that someone else will not have to do it, right? So I think that's kind of like that shift there.
No, I mean, then that makes
Again,
sense.
yes, it's how you see your data, how you see your problem, and but like this kind of use cases for streaming are kind of many times very different from what you would be doing on the application domain, right? Where you need to have that processing acknowledgement. You need to have more complex routing. Say I want to have round robin, per key ordering on, but at the same time be able to scale to many consumers, to many workers for your tasks and so on.
Yeah. I mean, okay, so that makes sense. It's a really weird, complicated thing because so many people have different opinions, right? And that's why I bring it up.
Of course.
Is depending on who you ask, what company you talk to, who in the space, they'll say it's the exact same thing. You don't need or they'll say messaging is an old school concept. It's done, and why would you bother with it unless you are running those old school things that Tim was mentioning, right? The super legacy enterprisey space. And it's not as straightforward as just, like, oh yes, one stream to rule them all. It's more than that. Now,
yes, the terminology is always very, very tricky because people will use the same words for meaning different things, right? And then other people will get very, very confused for when you say that Kafka is not a messaging system, or Kafka is not a queue, and then someone else say that Kafka is a messaging system, and so on. So there's all these things, right? But if you go down and see what all these systems are designed for and what are best suited for, then I think it's more clear what the meaning is for stream messaging, streaming, or queue, or topic, and so on.
So Matteo, so as people start to deploy Pulsar, what are the biggest mistakes you see them make?
To some extent, I think this is like also back some like autocritique, self-critique, as in that if you see people like using the APIs or the system that you design in the wrong way means that there is room for improvement, right? So that
Okay. Is there room for improvement right now?
I don't know. But so one funny thing is that I've seen in the past many people using databases to implement queues. I also see people use a queue as a database, right? So that's kind of like the
So okay, so that's an
the
interesting
reverse
point. So
problem.
what you're saying is with the real time kind of like analytics processing that's available to connect up to your stream and do some real time analytics, you're saying people are starting to ditch the relational or ditch a document database or whatever, a traditional database system, and just saying, well, we're just going to use the queue. We're just going to use the stream.
I, I think in some cases, some people are promoting that idea that your stream is your database, right? And that you don't need anything else, which I think is a bit
I'm a
overly
database guy,
optimistic.
so
Or
to
like,
me that makes me throw up a little. Just saying.
But yes, yes, there is a database table is a view of a stream, right? At the same time, a stream is a sequence of events that can lead to that. But from a logical perspective, right? But if you look it from a more like a concrete perspective of like a storage and how things work under the hood is very different, right? And
Oh yeah,
in the
I'm
same way
shocked that
that you
people would
have
do it.
in the same way that you don't have a single database engine that works for everything, right? From OLAP or LTP or like for like even like different. I mean, Postgres is very flexible and so on, but is not the only answer there, right? So, like extending that to a messaging and to a streaming platform that is everything you need. Yes, you can have key values access to a certain extent. And we also have it, right? We have added the table view option that you can see your topic as a key value pairs, right? And that works very well for certain use cases. Now, saying is that your only database? No,
Yeah,
you could use that in saying you could replace some database usages with that, right? So if you need to store key value pairs and you have a Pulsar around, then it's a very good option for some use cases. And for example, like we use it internally for things like we are redesigning the new load manager for Pulsar. We are going to extensively use this table view approach, right, to broadcast notifications and information across different brokers and seeing those as a database table. So that is kind of like the main idea, right? But from there to say that this is the database, that's a different story, right?
Yeah. No. I mean that's shocking. So, yeah, I'm not. I'm just going to pretend you didn't say that because that just hurts me. I mean, like when you say like we're going to ditch database and just stick it all in a stream or in Pulsar, that just hurts me. I'm just going to say that. So I know that we've worked hard as a community to add more features and continue to evolve Pulsar. What is the most underused or misunderstood feature?
That's a good question. I think we got called multiple times by people that say, I just discovered this feature X, and after like many months that I was using Pulsar, and they say that you guys don't even advertise this feature. This is a great feature, and you're not even advertising it. I think we have several of these, but
Well, tell us which ones so they can stop wondering and figure it out.
I mean, this one in particular was around delayed delivery, right?
Okay.
For example, like that you can publish a message and either put like say absolute time for delivery or relative, say deliver this in 3 hours. Essentially, you can be the scheduler for your messaging for your messages. So
Oh,
and
okay.
again, that's like everything that there's some operational limits to that, but it's kind of like this scalable, and it's very powerful because you can have messages with different delays. For example, you can have this one in 1 hour, this one in 3 hours, this one in 2 hours, so you can mix and match. And
well,
have
this is like the Tim example, the Tim account example, where if we're creating a Tim account and he's going to start next week, I can say delay this message or delay the account creation for 7 days.
Yes, so you don't have to worry about that. So you can just publish this, and then maybe some other account now is in 3 days. It gets published after, but now the delay is shorter. So and that each of them will be delivered and processed when the time is ready, right? So that's kind of the idea there. So this, I think, this is an underused feature because it's not super flashy and put into the eyes of user, I guess.
So out of curiosity, if you're using this more in like a streaming capacity where you're trying to log an order, would the order of it then be when it was actually delivered? So it would then.
So the point there is that the data it is written and it has that timestamp delivered at this timestamp, right?
Okay.
When you consume the data, you can decide how do you want to consume it, like always, right? So sending data is one thing, consuming data is a different thing, right? And you can consume it in different ways. The same data you can consume it in multiple different ways. So if you can consume everything in order as it was written, so you can just scan through and you get that, and you can check the timestamp by yourself and so on. At the same time, you can consume it with a shared subscription or key shared, and that will basically will get delivered at the right time. So, and of course, out of order, right? Because if you put the whole point of this exercise is that you might have different delays for different messages.
Okay, that makes sense. So you were going to tell me another underused or hidden feature.
This one is probably not very hidden, but I definitely think it is underused. It is the key shared subscription, essentially like having you can dynamically add many more consumers and without having out of order. So basically, you retain the ordering properties of your data, and so that it becomes per key ordering, but you can keep adding more consumers. So this is very, very powerful because you can use that to say same key, same user goes to same consumers, and everything gets delivered in order. And I would add one more, which is I think this is even more hidden, I guess, which is the replicated subscriptions. And that feature basically is about so as you know, Pulsar supports geo-replication, right? Geo-replication, you can have cluster A, B, and C, and you can publish here, consume from any of these clusters, right? And so basically, it is a full mesh replication across multiple clusters, and the clusters are independent because you don't want to have like a dependent infrastructure, so that if cluster A is completely in a bad shape, it shouldn't affect B and C, for example. So you want as much isolation as you can to avoid having outages creeping from one class to the other. But one common problem there is that when you want to have a cluster failover, you want to switch from, say, cluster A is completely down, there was a site outage, everything is down, I want to migrate my application from A to another cluster. And switching producers, it is easy. You can just publish in any of the clusters, fine. But switching consumers, it is a bit more trickier. As in, consumer, they typically have a subscription, right? So, and the subscription, it is local to one of the cluster that keeps your position in the topic. Now, if you go directly to cluster B, the cluster B will say, okay, your data is there, but I don't know where you want to consume it from, so I will start you from the very end, right? So we don't have that information on what you have consumed and what not. And to make things worse, since we are like a very generic, very general purpose, you can have producers in any of the clusters, right? That means that the local history is different in each cluster, because the order, there is no total order across a global system, right? There's
Right.
only order within each, there's per producer order within a single cluster, but the story that gets written in one cluster A, it is different from the story that gets written in cluster B, potentially, if you publish from both sides. That means that the message IDs are not going to be related, right? So each cluster has its own sequence of message IDs. So you can just say, okay, I had this message ID here in cluster A. I can just go on cluster B and say, I want to consume from this message ID. That doesn't work. So because of that reason, we added this replicated subscription concept. And so the usage of that is very easy. You just have to mark that as a subscription, replicate my subscription state in the consumer, and that's a flag, and that's it. And with that flag, you can now go from A to B, and you basically have your subscription that is kept in sync. So basically, you subscribe to A, and the system will make sure that your subscription, and you consume messages in A, you acknowledge in cluster A, and cluster A will send updates to cluster B, such that it will move your subscription cursor forward in cluster B.
And so that would help in a lot of use cases. I could see where that, if you've, for instance, got, let's say, spot instances, or you're using like, elastic resources in the cloud where you're bidding on things, maybe one region, for instance, all of a sudden gets cheaper substantially. So you use more, worker nodes or, applications in one, and then it drops down and it flips to another one. So you could do some fancy mojo in the background to, that's kind of a very interesting and cool, unique feature. Definitely super helpful. Let me end with this question, since we talked a little bit about those. Oh no, go ahead, finish.
No, please go ahead.
Oh no, I was gonna ask a last question, but if you wanted to finish talking about that, do it.
Oh no, I was just saying that is the surface that is very simple to use. The inner details are much more complex, as in that we have to keep markers flowing to keep track of the state back and forth between all these clusters. And I gave some points, some talks about it. So it's a very long descriptions, but it's also like very interesting to show like how this thing works, because there's a lot of kind of like distributed systems theory there behind on how to make that happen.
Yeah, it's easy to use, but complicated to actually make work in the back end.
Yes,
definitely. So all the complexity's hidden from you, so you don't have to figure that one out. So we talked a little bit about the features that are misunderstood or maybe not known. I want to know, in the last couple of minutes we have here, what is the thing that you're seeing that's being worked on that's really exciting? Like, is there a new feature or a new thing that is starting to be worked on that just is like, wow, this is very cool. I'm very excited about this thing.
To me, the biggest thing is, there's a bunch of work that we have started doing around incrementing the number of topics that you can support in a small cluster. For example, so we always say that person scales to millions of topics, and yes, with a non-trivial amount of brokers, right? You can make it to millions of topics. But we want to make it much more cheaper to have tens of millions of topics in a small cluster, for example, like make it much more feasible and cheap to run a very large amount of topics for a use case. And the purpose of that is that I believe that it will open a lot of make possible many use cases in which you don't have to convert from your business domain, the way you see one resource, to a different thing in the messaging domain, right? Like if you can address each and every resource with in your model with the topic, that makes your architecture much easier to reason about. And instead like multiplexing everything into a single one topic, in which you lose basically all the isolation, you lose all the addressability of a single resource, and so on. So I think that's it. And there are multiple pieces that have to get in to achieve that. That is one. Matrix system is another. Load manager redesign is another. So there are multiple big things there, but it will really be very powerful to achieve that.
Awesome. Tim, any final words for Matteo? He's muted. He. I can't hear him. Can you hear him, Matteo?
No.
Tim's just talking, and we can't hear him.
Sounds about right. Welcome to the Zoom age. I can't wait to be in person next week in Chicago. I think this is going to be one of those ones that we got to make sure everyone goes back and listens to it a couple of times, because there's some really important historical and current bits of knowledge that we have to really pull apart and learn from. This was a really good episode.
Yeah, well, I think the most interesting thing for me is the philosophy of you had to build for this large scale, but then scale it down. So a lot of the challenges were worked out early at the scalability side, and then you worked it back down to work with the smaller, components. That's interesting, right? It's generally somebody starts with.
I think it's easier this way than the other way around.
Yeah.
As in, I mean, just last pun here, but it's like I think that all the systems that have solved the easy problem before, and then it's, oh yeah, we're going to solve the replication or the storage later on. These are kind of like the first thing you should be solving, rather than going the other way around, right?
Yeah. Well, Matteo, thanks for swinging by. Appreciate you chatting with us and giving us a little background. And we appreciate everything that you've done. So until next time, this is the Crossing the Streams podcast. Go ahead, like, subscribe, give us kudos, ask us questions, whatever in the comments. We'd love to hear from you. All right, we're good.